The changes of state of a substance during heat absorption or release can be visualized on a heating or cooling curve. The y-axis gives the temperature, while the x-axis shows the heat gain or release. Let us look at the steps on a heating curve first. The solid at point A starts at a lower temperature than its melting point. From A to B, the solid absorbs heat while raising the temperature. At point B, the substance is still a solid, but now at the melting point. From B to C, the substance absorbs heat, but there is no change in temperature. So the region B to C is a plateau, which we call the latent heat of fusion. When the substance comes to point C, it has turned completely to a liquid, but still at the melting point of the substance. C to D, the substance absorbs more heat, now at a liquid state, while raising the temperature. When it comes to point D, the substance has turned completely to the liquid at boiling point. When the substance absorbs heat from D to E, there is no change in temperature. This region is called the latent heat of vaporization. Because the heat of vaporization of a substance is larger than the heat of fusion, the plateau dE is longer. So when the substance comes to point E, it has turned completely to a gas or a vapor, but still exists at the boiling point of the substance. E to F, the vapor temperature increases with absorption of heat. A cooling curve is a diagrammatic representation of the cooling process of a substance as its heat is removed. Initially, the diagonal line AB shows the removal of heat from the gas until it condenses. At the boiling point or the condensation point, a horizontal line BC is drawn to indicate the condensation of the gas to form liquid. After all the gas has turned to liquid at C, further cooling lowers the temperature, which is shown by the diagonal line CD, from the condensation point to the freezing point. At the freezing point, another horizontal line DE indicates that the liquid is changing to a solid state while keeping the temperature constant. At point E, the substance has converted completely to a solid at its melting point. Once all the substance is frozen, the removal of more heat decreases the temperature of the solid below its freezing point, as shown by the diagonal line EF.